Okay, we are getting started on our final geometry lesson of the year, if you can believe it. So this is section 11.6. We're going to find the surface area and volume of spheres today. So our learning target is I can find both the surface area and volume of a sphere and find the radius when given C or V. And C and V stand for circumference and volume, but that just felt like a whole lot to type out. So you could write that as given the circumference or the volume, and I'll show you a few examples of that in just a couple minutes. Okay, so for your entry task, we're going to find volume of both of these shapes to the nearest tenth if necessary. I'd encourage you to just pause your screen, please, and take a couple minutes to try out these problems. Okay, if you haven't paused, go ahead and pause now. I'm going to go through these questions really quickly. On this pyramid over here, notice that the height is sort of tilted off to the side, but still from the vertex down to the square, it's 5 inches, and then this square is 3 by 3. So everything's kind of coming up all at once here, but our volume formula for a pyramid is 1/3 base times height. I went ahead and just kind of put the base in there. It's 3 times 3, which is 9. So 1/3, 9 times 5. This is an acceptable way to show your work, right? Because I could go back and say, oh, this person calculated the base incorrectly, right? If you had written out 9. So just make sure that you're kind of showing the numbers that you plug into your formula, please. 1/3 of 9 was 3, so I rewrote this as 3 times 5, and then 3 times 5 is just 15 inches cubed. And then for the cone that's over here, remember that our formula is, again, 1/3 base times height, but since the base is a circle, another way to write that is 1/3 pi r squared times the height. Or what we actually had in our lesson from last week was base times height divided by 3, or pi r squared times height divided by 3. And again, you can write them either way. It's going to get you the same answer at the end. So to find the volume, my pi r squared was 4 pi, right? That's my base, 2 squared, sorry, times pi. And then my height is 7 because it's going from the vertex down to the base. So that's 1/3 times 28 pi. Well, 1/3 of 28 is 9.3 repeating forever and ever and ever. So I used 3.14 for pi and got 29.31 miles cubed. If you use the pi button in your calculator, it'll get you 29.32. So as long as you're kind of in that 29.3 range, it's only to the nearest tenth. So 29.3 would be your final answer. Okay, so we are talking about spheres today. This is our last shape that we're going to be learning about in this chapter and in the whole entire year. And I really like spheres because they're actually, they're pretty straightforward. So we're covering surface area and volume just kind of all in one fell swoop today. Get it out of the way, and then we're just reviewing for the rest of the week. So some vocabulary here. A sphere is the set of all points that are equidistant from the center. So if you have the center of the sphere here, all this fancy language means is that if you are looking at the outside, right, kind of the edges of the sphere here, every point that you would find on the sphere is going to be an equal distance, right, equidistant from the center of the sphere, right? So let's say your radius here was 5 inches, right? Every piece of this sphere, of the outside of the sphere, is going to be 5 inches away from the middle. So a sphere is not forming any kind of like a football shape or an egg shape or anything like that. It's got to be a perfect, nice, round, circular sphere. So it forms this ball-like 3D shape. The radius is obviously, just like in a normal circle, it's the segment from the center to the end point on the sphere. And again, because this is a three-dimensional figure, rather than just going from the center to any of the sides here, it could go, up to the top of the circle or down to the bottom, or of the sphere, or down to the bottom of the sphere or towards the front of the sphere. It can go kind of three-dimensionally for the radius, but it still has to go from the center to an endpoint that is on the sphere. Then the diameter, obviously, just like in a normal circle, again, it's a segment connecting the endpoints and it has to go through the center, right? So I could not draw a diameter like up here, for example, and just make some random, pretend that's a straight line. If I drew this as a perfect straight line, right, if it doesn't go through the perfect center of the circle, then it's just a line, like it's just another segment, but it's not a diameter. And then same thing with the circumference. The circumference has to be the biggest circle that wraps around the sphere. So it's formed by the radii, right? But it cannot be some random circle. And again, this is going to be terrible, so I apologize. If I just sort of drew a random circle connecting some of the points in the sphere, that's not a circumference because it doesn't go around the biggest part of the sphere and it's not formed by radii. So essentially, all of the words that we're talking about for spheres here, radius, diameter, and circumference, they're pretty much exactly the same as what we would use for a circle, but now we're just talking in 3 dimensions instead, right? So now we have like more to work with. Okay, so really quickly here, the formula for the surface area of the sphere is super quick. It's just 4 times pi r squared. So basically we're taking the area of a circle and multiplying it by 4, and that's it. So this is a nice little just visual up here, right? If we sort of unwrapped or unstitched a baseball, the area of each circle here is pi r squared. And obviously this isn't a perfect diagram, but if you could imagine, right, there's actually essentially 4 circles that cover up any sphere. And so this is our formula. So for example 1, it asks us what's the surface area of our sphere, right? So we have a sphere right here. We know that our surface area is just super straightforward, 4 times pi r squared. I will tell you, when I first made my PowerPoint, I made the mistake of using 10 as my radius, but we are better mathematicians than that. And we know that our radius here should be 5 because 10 is actually the diameter. So I had to go back and change my work there. So it would be 4 pi times 5 squared, which is 4 pi times 25, right? Pi r squared. And then 4 times 25 is 100, so it's just going to be 100 pi meters squared. And unless it specifies otherwise, I'm just going to stick to leaving my answers in terms of pi. On example 2, it says if C equals 40 pi meters, what is the SA? Remember that C is going to mean circumference for us, and SA is just going to be surface area. So we know that our surface area formula is 4 pi r squared. So in order to find the surface area, we know what 4 is, we know what pi is, we just have to figure out what the radius is. So our goal here is going to be to start with the circumference and work our way backwards to find the radius. So if the circumference is equal to 40 pi meters, right, that just comes straight off of our problem there. I also know that the formula for the circumference, like if I was to try to find the circumference by myself, we had 2 different formulas for that. It was either 2 pi times the radius or pi times the diameter, right? Because the diameter is essentially just 2 times the radius. Well, what that tells me is that my diameter up here is just 40 meters, right? Because I can basically just take that pi off of it and say, okay, what's left over? 40 meters. And if the diameter is 40 meters, the radius is half of the diameter, and so the radius must be 20 meters. So this is kind of your starting point always, is work your way backwards to the radius, and once you know the radius, then you can plug it into the surface area formula. So now that I know that my radius is 20 meters, I can just plug it into the formula, 4 pi r squared, 20 squared is 400, and that gives me 1600 pi meters squared. And again, I'm just leaving it in terms of pi. Okay, so the formula for the volume of a sphere, so we're moving away from surface area here, is 4/3 pi r cubed. Now, this is one that is a little bit trickier, like I can't just show you a picture of a baseball to prove why this one works. So again, just like last week, I'll try to put a little video down in the description, a link so that you can see sort of a proof of how this relates to cylinders and how this relates to other shapes and where this fraction of 4/3 and the r cubed comes from. I'm not going to go through all that now because I just want to give you kind of the basics in this lesson, but if you're interested, I would encourage you to go and watch that video. So make sure you write this formula down because you are going to need it quite a bit on your homework tonight. So on example 3, we are just going to find the volume. So we have a radius here of 6 meters, and our volume formula is 4/3 pi r cubed. One thing I want you to really pay attention to here as we're going through this problem is this cubed on the radius. That means that we're essentially saying radius times radius times radius 3 times, right? And we are really, really used to just doing radius squared because that's our habit from doing like the area of a circle. So a lot of the time students will forget to do the radius multiplied by itself 3 times. So just be careful. So since I know my radius is 6, I'll just plug it in. So 6 times 6 is 36, right? But because we're cubing it, I have to do it times 6 again. So 6 times 6 times 6 is actually 216. There's a few different ways to simplify from this point. My favorite way, or what I think to me is like the quickest way or the simplest way, is just to multiply all the top numbers, right? So 4 times 216 times pi, so that gives me 864 for just kind of my numbers on the top. And I left my pi off to the side there, and I still have it divided by 3. So now I'm just going to do 864 divided by 3, and I get 288 pi meters cubed. And again, since it didn't tell me to round to the nearest tenth or round to the nearest hundredth or anything, I'm just going to leave it in terms of pi here. All right, so our final example here is if the volume is 500 pi inches cubed, and by the way, note on our last example, right, the units should always be inches cubed or meters cubed because we're talking about volume now. It asks us what is the radius, so we're going to work our way backwards. We're going to start with the formula, just like we did in chapter 10, and we've done it a little bit already in this lesson today. My volume formula is 4/3 pi r cubed. Well, I know that my volume is 500 pi inches cubed from up here. 4/3 is just a fraction. Pi represents 3.14. So my only variable, right, my only unknown in this equation is the r, the radius, which is what we're looking for. So we are good to go. So the first thing I notice when I look at this formula is that I don't really like to have fractions in my equations when I'm working with them. So my first instinct is let's get rid of that fraction. And there's other places you could start. I'm just, because this is my preference and I am making the PowerPoint, I'm going to start here. But you are welcome to choose a different path and see if it leads to the same place. So I'm going to multiply both sides by 3. Sorry, that 3 looks kind of weird. And that makes the 3 on the bottom cancel out over here, right? 3 divided by 3 is 1. But then 3 times 500 gives me 1500 on this side. And then of course I still have a pi here, and then I still have 4 pi r cubed on this side. The next thing I notice is that pi represents an irrational number, and I don't really want to deal with that right now. And I notice that I have a pi on both sides of the equal sign, so I can actually divide both sides by pi, and again, pi divided by pi is 1, so that just, right, it just cancels itself out. So now I just get to deal with some nice kind of straightforward numbers, 1500 and 4. And I still have r to the third here. So I'm going to divide both sides by 4 to get r by itself. So 1500 divided by 4 is 375 equals r cubed. I'm not quite to the radius yet, but I am pretty much out of space here. So I'm going to restart my work up here. So 375 equals r cubed. To get rid of a cubed, right, r cubed, I actually have to take what's called the cubed root on both sides. So that means I'm trying to figure out what number times itself 3 times equals 375. So I actually used my calculator for this one. There should be on most calculators. I know on your phone calculator, there is a cubed root button if you do the second feature. It depends, like we've talked about this in class, it depends on your calculator how to access the cubed root button. So if you are having a hard time figuring out how to use your calculator, maybe just send me a picture of your calculator through Teams and I'm happy to help you troubleshoot your own calculator. Just be careful though, a lot of people will want to take the square root of 375 and that will get you a number that's a little bit too big. The square root of 375 is actually 19.36 approximately, so that's quite a bit larger than 7.21. So I'm just going to round this to the nearest hundredth because it didn't tell me what to do here. You could even probably just leave it as 375, the cubed root. I will mention though that on the homework, you are asked actually to find the surface area given the volume. So in a problem like this, it'll say if the volume is 500 pi inches cubed, what is the surface area? So this is a note you just might want to write down. You're going to want to use the volume to find the radius like we just did here, and then use the radius to find the surface area. So kind of like example 2 that we did earlier where we used the circumference to find the radius and then use the radius to find the surface area. Same idea. Always find the radius and then you can pretty much use that to find anything in a sphere. All right, so for summary, if you want to kind of reflect on this question or write it down in your notebook, again, you don't have to, I'm not there watching you in class, but if it helps you to just kind of have a little reflection. How do you find the radius given the circumference or the volume? And just for your own benefit, for your own learning, in your notebook, describe those steps. And then your assignment will be page 737, which you can find in your textbook or in Teams.